Okay, so in this video, we're going to be talking about expanding binomials using Pascal's triangle. Now, I'm not going to talk about how to expand out Pascal's triangle. I'm going to assume you already know how to do that if you're on this video. So we're just going to talk about how we can use the triangle in order to expand out a binomial. And you can see that I have a portion of the triangle written down here. And what we're looking at is this diagonal right here on Pascal's triangle, because we know that that diagonal will correspond with the exponent value on the binomial. So for example, if you look at this row right here, you can see that on that diagonal, I have the number 3. And that number 3 represents the exponent that's going to be on that binomial that I'm going to be trying to expand out. Meaning if the binomial has an exponent of 3, I'm using this row right here, and I'm going to be using these coefficients 1, 3, 3, and 1 when I go to expand it out. Okay, now this will make a lot more sense as we're going through the problem. So why don't we go ahead and take a look at our first example, and we'll talk about how we're going to do it. So here's our first example, and they want us to expand out the binomial. And so just keep in mind, Pascal's triangle only works for binomial expansion. Like I can't expand out a trinomial using Pascal's triangle. It's only when you have two terms, or in other words, a binomial. Now there's two ways you could do this problem. You can simply just do x plus y times x plus y times x plus y. So again, x plus y times x plus y times x plus y, and then multiply the entire thing out. That's totally fine, okay? But as your exponent starts increasing in value, let's say this becomes like a 7 or a 5, all right, that's going to be a lot of work, and that's where Pascal's triangle comes into play. It can make expanding out binomials much easier. So let's talk about how we're going to do that. So let's go ahead and get rid of this stuff here. The first step that you want to do is identify what your exponent value is. In this case here, my exponent value is 3. So you want to go back to Pascal's triangle, and you want to select the appropriate coefficients that correspond with that exponent of 3. So real quick, why don't we go ahead and go back to Pascal's triangle? That way we know what row we're going to be using. So we're back on Pascal's triangle, and remember, we're looking at this diagonal here, okay? Now, the exponent on our binomial was 3, meaning our coefficients that we're going to be using are 1, 3, 3, and 1. So you're going to want to write that down. So again, the coefficients we're going to be using, 1, 3, 3, and 1. Let's go back to the original problem now. So here we are back at the original problem, and I'm going to write down those coefficients, 1, 3, 3, and 1. And so now expanding it out is pretty simple. And to do that, you're going to start with the first coefficient, which is 1. So I'm going to write 1, and then I'm going to write my first term, which is x, times x. And then I'm going to multiply by my second term, which is y, times y. Just leave it like this for now, okay? Then you're going to put plus. Go on to your next coefficient, which is going to be 3, okay? So I'm going to write 3, and then my first term, x, and then my second term, y. Okay, then put plus. Go on to your next term, which is also going to be 3. I'm going to write 3, then I write x, then I write y, and then I put plus. I go on to my last term, which is 1. So I write 1 times x times y, and there we are. From here, all you have to do is one more step, and it's pretty simple. You're going to go back to your very first term that you wrote down, which is right here, 1 times x times y, and you're going to start inputting in your exponent value. So for example, your first term here of the binomial is going to be x. That means you're going to write the entirety of the exponent value, which is going to be 3. So for example, I'm going to put 3 here, okay? Your second term of the binomial was y. That's going to get an exponent of 0. And then from here, it just follows a pattern where it goes down 1, and then you add 1. So for example, on my next term, I'm going to write a 2 here, and then here I write a 1. And then on my next term, I write a 1 here, and then I put a 2 here. So you can see it's going down 1, and then I'm adding 1, okay? And on my last term, I put a 0 here, and then a 3. And there it is. So now when you expand it out, what is it going to look like? So start with your first term. Well, we know that anything to the 0 power is going to be 1. So technically, this whole part here is 1. I can just go ahead and cancel it out. I'm just going to be left with x cubed. So my first term here is going to be x cubed. Okay, that part's done. Going on to the next part, I have y to the first power, that's y. I have x squared, and then 3. So plus 3x squared y, okay? Going on to my next term, I have 3 times x to the first power times y to the second power. Well, that's going to be plus 3x and then y to the second power. And then finally, my last term, again, I have another variable to a power of 0. That's just going to be 1. So this will cancel. I have 1 times y cubed. That's just going to be y cubed. So plus y cubed. And there it is. It's completely expanded out. That's done. Okay? All right, why don't we go ahead and try another example? So here's our next example. A little more challenging because now you have a 2x, not just an x, and then minus y. Now we do have a negative here. We have to take that into account when we expand it out. So how are we going to do it? Well, our first step, we want to list out our coefficients. Your exponent here is 5. So we're going to go back to Pascal's triangle and identify what coefficients we need to use here. So here we are back at Pascal's triangle. I still have the work we did on the previous problem written here, but that's okay. I know that I have an exponent of 5, so that means I'm going to be using this row right here. So I have 1, 5, 10, 10, 5, 1. And so those are going to be my coefficients. So I'm going to go back to the original problem and I'm going to write down these coefficients. So here we are back at the original problem. I'm going to write down those coefficients, which were 1, 5, 10, 10, 5, and then 1, okay? And so you're going to need some room when you expand this out, so make sure you give yourself room, but we're going to start on our first coefficient, which is 1, and start expanding it out. So writing our first coefficient, we have 1, and then going to the first term of our binomial, it's going to be 2x. And then our second term is a negative y. Make sure you include that sign. It is a negative y, okay? And so again, I'm going to wait to the very end until I start filling in the actual exponent values, okay? Then I put plus, my next coefficient is 5, so I put 5, and then again, 2x minus y, and then plus, my next coefficient is 10, so 10 times 2x times the negative y, plus my next coefficient is also going to be 10, so 10, and then I have 2x, and then minus y. My next coefficient is going to be 5, plus 5, and then I have 2x, and then minus y. And then my last coefficient is 1, so plus 1, and then 2x, and then minus y. Okay, so this one is definitely longer. It's going to be a little more challenging, okay? Let's start filling in our exponent values now. So here's my first term of the binomial, 2x. I'm going to put the entirety of the exponent, which is 5. And then my second term of the binomial gets an exponent of 0. And then we follow that pattern where we go down 1 and we add 1. So this becomes 4, this becomes 1, this becomes 3, this becomes 2. This becomes 2, this becomes 3, right? 1, 4, and then finally 0, 5. So I like to do the easy parts first. Anything to the 0 power we can essentially cancel out. So for example, this will cancel and this will cancel. And then starting on our first term, what do we get here? Well, I have 2x all to the 5th power. Now remember, this exponent of 5 is actually being applied to both the 2 and the x. So you have to do 2 to the 5th power as well as x to the 5th power. So when I do 2 to the 5th power, I get 32. So I'm going to write here 32 and then x to the 5th power. Okay, that part's done. Let's move on to the next part. Here I have 2x to the 4th power. So again, that has to be applied to both the 2 and the x. So 2 to the 4th power is going to give you 16. And then 16 times 5 will give you 80. But then I have this negative right here, this negative y to the 1st power. So it actually becomes negative 80 and then x to the 4th power and then y, just like that, okay? Then moving on to our next part here. We have 10 times 2x to the 3rd power and then negative y squared. Now we know that negative y squared will essentially become positive y squared when we do that. And again, this 3 has to be applied to both the 2 and the x. So 2 to the 3rd power is going to give you 8. And then 8 times 10 is 80. So I'm going to put plus 80. So plus 80. And then I have x cubed and then y squared. Okay? Now moving on to the next part, you can see that I have this negative y cubed. That's going to remain negative. So the end result there will be a negative y cubed, right? Because my exponent is odd. So it's going to remain negative. And again, this 2 here has to be applied to both the 2 and the x. So what ends up happening, I get 2 squared, which will give me 4. And then 4 times 10 will give me 40. And remember, I still have this negative that never went away, so it becomes negative 40. So I'm going to write here negative 40. And then taking care of your variables, you'll have x squared. And then y to the third power. Okay? Going on to my next part, I have 5 times 2x to the first power, which is really just 2x. And then I have negative y to the fourth power. That becomes positive now. So now it's positive y to the fourth power because, again, my exponent is even there. So if you have a negative base and your exponent is even, the result will be positive. If you have a negative base and your exponent is odd, the result will be negative. But here it's going to be positive. So I'm left with 10x, so plus 10x, and then y to the fourth power. And then finally, our last part here, I just have negative y to the fifth power times 1. So my end result here is going to be negative y to the fifth power. That's it, okay? And that's completely expanded out, all right? So in my opinion, that's much easier than multiplying the whole thing out like you typically would side by side. I think using Pascal's triangle here is a little bit easier, and that's essentially how you do it. So why don't we go ahead and try one more example, and then we'll be done. So here's our last example. This time we're dealing with an exponent of 4, so not as high as 5. All right, but we have a 2x and a negative 3y. Why don't we go ahead and get our coefficients that we're going to be using for this problem? So we need to go ahead and pull up Pascal's triangle. So using Pascal's triangle, you can see that I'm going to be using this row right here. So my coefficients that I'm going to be using are 1, 4, 6, 4, and 1. Let's go back to the original problem and record down those coefficients. So here we are at the original problem. Let's go ahead and record down those coefficients. We get 1, 4, 6, 4, and then 1. And from here, we can go ahead and start expanding it out, okay? So starting with my first coefficient, which is going to be 1, I'm just going to write 1. And then the first term of my binomial is 2x. The second term of my binomial is negative 3y. And we're just going to keep doing this, and then we'll take care of the exponents at the end. So then I have plus 4, and then 2x, and negative 3y. And then plus my next coefficient will be 6. So then I have 2x and another negative 3y. Okay, plus my next coefficient will be 4. So I put 4, 2x, and then negative 3y. And then our last coefficient here is 1. So plus 1, and then 2x, and then negative 3y. Okay. Let's go ahead and start taking care of these exponents now. So again, starting on our first term, we know that this 2x will have the entirety of the exponent, so it will be 4, and this will be 0. And then we follow that pattern of going down 1 and then up 1. So this becomes 3, this becomes 1. This becomes 2, this also becomes 2. Then we have 1, then we have 3, and then finally 0, and then 4, okay? So again, anything with a 0 power, go ahead and cancel it out because we know that that's going to be 1. So this will cancel. This will cancel. Let's go ahead and take care of it. So my first term here, I have 2x to the fourth power. And again, that's being applied to both the 2 and the x. So 2 to the fourth power is going to be 16. And then we have x to the fourth power. So we get 16x to the fourth power. Okay, that part's done. Moving on to the next part. We have this 2x to the third power. So that's really 2 to the third power, which will give you 8. 8 times 4 is 32. And then we have this part here, this negative 3y to the first power. So that's just going to be negative 3y. So I have to do 32 times a negative 3. When I do that, I get negative 96. So I'm going to put here negative 96. And then taking care of my variables, I'll have x to the third power. And then y. Okay, that part's done. All right, let's move on to the next part. So here I have 2x to the second power. We know that that's really going to be 4x squared when we do that out. And this part here, we have negative 3y to the second power. That's really going to be 9y squared. All right, so taking care of our coefficients, I have to do 6 times 4. That will give me 24. And then 24 times 9 will give me 216. And again, this will be positive. So I get plus 216 and then x squared and then y squared. Okay? All right, moving on to the next part here. I have this 2x to the first power, which is really just 2x, and then negative 3y to the third power. Well, what ends up happening there? I'll end up getting a negative 27y cubed there, okay? So I have to do 4 times 2 times a negative 27. And when you do that, you get negative 216, and then we get x, and then y to the third power. And then finally, our last part here, I have to do negative 3y to the fourth power. So negative 3 to the fourth power is really positive 81. So plus 81. And then we have y to the fourth power, okay? And this is done. All right, so this problem is completely done. We expanded it out using Pascal's triangle. And that's pretty much it. So that is how you do binomial expansion using Pascal's triangle. It can save you some time once you become proficient in it. It is a little bit weird at first. But just remember, when you start getting into things like the binomial theorem, that's essentially where this is coming from. The binomial theorem, which is how you expand out binomials with a higher exponent value, it's essentially coming from Pascal's triangle. So the binomial theorem is being derived from Pascal's triangle. So if you're good with Pascal's triangle, when you go on to the binomial theorem, it's going to be much easier. Okay, so that's pretty much it. I hope that you learned something from the video. I hope that you gained something. If the video did, in fact, help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future, and I'll see you in the next one.